So I've had a couple people ask me about the tracker and whether it's worth keeping the tracker, given I've had so much trouble with this thing since I've gotten it, and whether it'd be just worth getting rid of it and replacing it with just some additional solar, fixed solar. And it's a good question, but I think this morning, given the fact that we've got this little scrim of cloud cover, will make a good day to do a video on just exactly why I think it's still of value to me to keep the tracker going and keep it producing as much power as possible that way. So I have had a lot of trouble with the tracker, and I think the one of the misconceptions is that I'm trying to just get more overall solar in my day by tracking the sun and keeping the panels pointed at the sun all the time. And while that is an advantage, the main reason why I have the tracker is to pick up the sun earlier in the morning and hold on to it later. So I want my solar day to start earlier and end. Thanks for that, Molly. So I want my solar day to start earlier and end later. So right now, I'm going to show you the difference between having the tracker and not having the tracker and how long my solar day is as a result. All right, so you can see that the array, the tracker array is pointed totally east, and right now we are making about 145 watts off the main array. It's first thing in the morning, not a lot of power. But if we look at the tracker, we are already making off of a 600 watt array 352 watts. So obviously, huge advantage there. Starting my solar day much earlier as a result. That means that right now, this will cover my load if I have my power on. Whereas if I didn't have the tracker, I wouldn't be covering my load right now. I'd be drawing off my batteries. Now, on a sunny day, a little bit earlier, this image taken on a sunnier day, a little bit earlier than it is now, about 6:35 in the morning, you can see that just as the sun's coming over the top of the mountain, the main array only making about 13 watts, but the tracker already, first thing, making over 250 watts, which meant that right there at 6:35 in the morning, I was already covering my load. So, and if we look at how long it actually took for that main array to catch up and actually make a similar amount of power, you can see it's 8:30 in the morning, and it still is trailing the tracker. It's making enough power to cover load, just barely, but it is actually still trailing the tracker all the way at 8:30 in the morning, after 8:30 in the morning. So that just shows you how much of an extension in the morning my solar day gets just by adding that tracker. So let's go outside and just take a look at the orientation of the arrays and just to see why it actually makes such a difference. So we can see that the sun actually is a little obscured by the clouds right now. But the angle is such that not much power is coming in on that main array. Whereas if we look at the tracker array, it's directly pointed at the sun right now and is going to track it for the rest of the day. And then when the sun gets over into the west and is at about the same angle to the main array as it is right now, the tracker will be pointed at the sun and it will be making similar power as it is now, 350 or so. When the sun comes out behind the clouds, even at this time of the day, that array can get up over 500 watts on that 600 watt array. Now, at the end of the day, it's even more dramatic because the mountain kind of plays havoc with my solar in the morning. But on the other side, there's no mountain, and you can see here at about 7:20 at night now, again, it's cloudy, so this would be even more dramatic on a day that it was sunny. But you can see the difference between the array, the main array, the 1680 watt array on top there, and the tracker array on the bottom. Now, again, if it was sunnier out, we'd have a much more dramatic difference here. But you can see all the way till 7, probably 7, maybe even 8 o'clock, I'm probably going to hold on to that sun and be covering my load at least until 7:30.